Good afternoon, all. Good afternoon, all.
Good afternoon.
Afternoon, sir.
I think you have remembered that in the previous class we were discussing about the regular operations on the finite automatas, and we have gone for a few of the construct by which we can show that how a finite automata is constructed. And here I am starting from the same one, revisiting all those, then I'll move on. Then starting the discussion, what I have studied yesterday, again I am revisiting all those things. Yesterday we have gone for the regular language and under which are the operations they are closed. Regular languages and the operations under which those languages are closed. That are the things we are discussing in the previous class. Then going for those concepts, you can see the slide. I have gone for some theorem. Regular languages are closed under the union operation and some other properties. These are the things known to you as I have gone for these things in the previous class. Still, I am revisiting it to go for some of the proofs. That is, yesterday we have gone for design, now I am going for the proofs of those design. How to prove that these concepts that we have discussed in design are correct. Okay, number. Then going for this concept, the slides are visible to you. Hello.
Yes, yes, sir.
Okay. The first theorem is the regular languages are closed under the union operation. And who can say what is the meaning of this? The class of regular languages are closed under the union operation. Rahul Senapati. Rahul Senapati. एक आ रहा है तो एक जा रहा है. अच्छे बच्चे. Rahul Senapati. Okay. Then one who can say what is the meaning of this theorem? Okay. Debajyoti Das. Can you answer? What is the line written? What is the meaning of that line? तुम्हारा भी माइक नहीं काम कर रहा है जगह अनन्या these two languages are equal राहुल कहाँ आ गया मैंने तो यहाँ पे इक्वल के बारे में बोला ही नहीं मैं रेगुलर लैंग्वेजेस के कॉन्सेप्ट में हूँ यू आर सेइंग दैट इट इज इक्वल इक्वल is something different than the regular case and here actually the meaning of the statement is और एक चीज बोल रहा हूँ जो जो दिखा रहा हूँ हो सके तो उसे लिखते चलो क्योंकि बनना बाद में कुछ फायदा नहीं होगा कुछ नहीं मिलेगा और theory of computation में there is no theory only the theorems are there if you want to go for the theory part then you have to remember the theorems and you have to understand them that's why I'm saying the theorems I'm saying if possible write in your copies then going for this I can say that the class of regular languages is closed under the union operation means let there are two languages. One language is A1 and the other language is A2. These are the things I have explained you yesterday. Still repeating again. And from these I'll move next. And there is a need to prove that A1 union A2 is regular. That means if two languages A1 and A2 is there, which are regular, then I have to show that A1 union A2 is also regular. It is same as the regular operations that we have studied in case of DFA or deterministic finite operator. वहां पे भी पढ़ा था यहाँ पे भी पढ़ रहे हैं. In that case, what we have done, we have gone for two separate automatons and we are joining them by union operation. You have solved a lot of problems also based upon that. दो ऑटोमेटा बना है और उसका यूनियन निकाल दिया. This is the same concept. If there are two regular languages A1 and A2, what do you mean by it? When a language is called regular? Satyanarayan Singh? सत्यनारायण सिंह तो काम करूंगा अभी जो जो नहीं बोलोगे उन सबको निकाल दूंगा आशुतोष मिश्रा
Yes, sir.
मिश्रा ये जो बोल रहा हूँ उसका हाँ बोलो
सर इफ उसका डीएफए बन सकता है देन उसे रेगुलर लैंग्वेज कहें.
नहीं थोड़ा सा चेंज होगा डीएफए बन सकता है ये कैसे बोल मालूम है तुम्हें if we can design a finite automaton for the language then that is called regular not DFA DFA
ओके.
means deterministic finite automaton but here what I am saying finite automaton तो finite automaton का मतलब क्या है how it is different than DFA
फाइनाइट ऑटोमेटा में दो टाइप्स के आते हैं ना, एनएफए डीएफए दोनों.
yeah that means finite automaton means we can design a DFA or NFA and as we have studied just before if we can design a NFA then also we can design a DFA
DFA.
ऑल्सो
and
डीएफए.
if we can design a DFA then also we can design a NFA that is for every NFA there is a DFA for every DFA there is a NFA that we
एनएफए.
have just studied one class before equivalence of NFA and DFA okay thank you then moving for this what I am saying if A1 and A2 are two regular languages that means we can design two finite automatas let one is N1 the other one is N2 then its union can be represented by a finite automata n. That we have to prove. Then going for the union of the finite automatas, this is the case that we have discussed yesterday. That is, if there are two automatons, then create a new initial state and join the initial state of both the automatons with a transition of epsilon. Create a initial state and join the initial state of two automatons with a transition of epsilon. This is the diagram that we have studied in the previous class. Okay? And this is its proof. Let there are two automatons. You just diagrams I think you have designed. You go for these proofs, write in a copy. Don't leave these. That's why I'm repeating it again only to go for these theorems. Let there are two automatons N1 and N2. N1 can be defined with the help of 5 tuples Q1, sigma, del 1, Q1 and F1. And N2 can be defined using the 5 tuples Q2, sigma, del 2, Q2 and F2. Here N1 recognizes A1 and N2 recognizes A2. And we have to construct a finite automaton N defined with the help of 5 tuples Q sigma del Q0F, which will recognize the automaton A1 union A2. That is our theorem that we have to prove. We'll go for this using the method of construction. To prove this by using the method of construction, we can say that the set of states is the states in the NFA1, that is Q1, and the states of the NFA2, that is union of Q1 union Q2, along with a new initial state Q0. That means the total number of states present in the union is equal to a new initial state along with the set of states present in N1 union with set of states present in N2. The new initial state will be the initial state of the finite automata. And the set of final states will be the union of the set of final states in N1 and the set of final states in N2. That means if this automaton contains 3 final states, the first one containing 2 final states, then their union will contain 5 final states along with an additional initial state. Hence, this is the theorem that proves that one. Any doubt? Any doubt?
सर ये वाला प्रूफ आ सकता है क्या एग्जाम?
प्रूफ तो सब आ सकता है, इसीलिए तो मैं बोला ना, ऑटोमेटा में अगर प्रूफ है तो वही थ्योरी है. देयर इज नो मोर अदर थ्योरी इन ऑटोमेटा. In automata, if you are getting a theory, that means you are getting a proof. That may come directly or that may come indirectly. ऑटोमेटा में अगर कुछ भी थ्योरी पार्ट है वो तो वो है proof. Or it is better to understand the proof rather than remembering it.
सर आप ये प्रोवाइड करेंगे सर नोट?
मैं तो दिखा रहा हूँ, तुम लिख लो यहीं पे, क्या प्रॉब्लम है?
जी सर.
अगर किया भी तो अभी नहीं करूंगा ना, बाद में करूंगा तब तक तो भूल गए होगे।
ठीक है सर।
क्योंकि ये दे दिया तो तुम लोग और क्लास भी नहीं आओगे, सोच लोगे पढ़ के हो जाएगा, और उसके बाद जब एग्जाम होगा तो मार्क्स आएगा 0। प्रॉब्लम वही है तुम लोगों का। इनमें कुछ प्रॉब्लम नहीं है, अगर मैंने दे दिया तो तुम लोग और क्लास में मिलोगे ही नहीं।
आएंगे सर ऐसे बात नहीं।
नहीं, मैं तुम लोगों को अच्छे से जानता हूँ, इसीलिए बोल रहा हूँ। तुम लोग पहली बार मेरे क्लास में हो, मगर मैं तुम जैसे बच्चों की क्लास में बहुत साल से हूँ। 2005 से लेके 20, 15 साल, 16 साल हो गया। ठीक है, तो देख लो वहाँ पे, ये हुआ इसका। Can understand, then you can write by yourself. The states will be states of the NFA1, union states of the NFA2, union initial state Q0. Right. क्या रिपीट करूं? ये वाला बताया था, सुने हो ना? The total number of states will be the states of the automaton 1, union the states of automaton 2, union a new initial state. जो यहाँ पे मैंने दिखाया है, यहाँ पे एक नया इनिशियल स्टेट करके दोनों को कनेक्ट किया। The initial state of the entire automaton is the initial state of the automata which was newly created. That is, this is Q0, the newly created initial state. The final state of the entire automaton is the final state of automaton 1 union final state of automaton 2. For example, if you go for this automaton, here the F1 is 2 states, here F2 is 3 states, and for this automaton, the total number of final states is 5. And going for the transition, you can say that the newly created initial state should be connected to the initial state of the automatons with the help of a epsilon transition. With the help of a epsilon transition. Understood? Understood?
Yes, sir.
Yes, sir.
Then moving for the next theorem. The next theorem is the class of regular languages is closed under the concatenation operation. Then what do you mean by concatenation? It means basically appending. It means basically the appending. That means if I am saying A1 N1 concatenation N2, it means N1 followed by N2. That means here I am saying that if there are two regular languages, A1 and A2, and we want to prove that the concatenation of A1 and A2, that is A1 dot A2, or also I can write A1 A2. Then this concatenation is regular in nature. Repeating again, if there are two languages which are regular, then their concatenation is also regular. And basically, whenever we are going to prove this, what we consider that if A1 and A2 are regular languages, then we can construct finite automata as for them. Let N1 and N2 are two finite automatas. And here we are considering about NFA because for DFA already we have gone for the proof previously. If there are two automatas N1 and N2 which are recognizing the languages A1 and A2, then we can implement A1 dot A2 or A1 concatenation A2 by generating a automata N as represented here. You have written this. I'm moving next. I'm moving next. अरे थोड़ा इंटरेक्टिव बनो.
yes, sir.
Yes, sir. वो mic थोड़ा on करो.
अरे माइक नहीं चैट बॉक्स तो है ना. Okay. Then moving next, I can say that if two automatons are there, N1 and N2, this is N1, this is N2. Here these two are initial states, these are the final states. What I have to do, I have to go for N1 and N2 and this can be represented like this. Then यहाँ पे क्या कर रहे हो? What you are doing to get the concatenation of N1 and N2? Saying clearly, try to understand. The initial state of the first automaton is the initial state of the entire automaton whenever it is concatenated. After concatenation, the final states are the final state of the second automaton. समझ में क्या बोला? Repeating again. For the concatenated automaton, मतलब यहाँ पे concatenation हो गया N1 से N2. Then what is the initial state of this combination? The initial state of first automaton is the initial state. The final state of the second automaton is the final state. Except that the final state of first automaton gets non-final. The final state of the first automaton becomes non-final and connected to the initial state of the second automaton with the help of a epsilon transition. Repeating again, the final state of the first automaton, देखो यहाँ पे ये final state becomes non-final, यहाँ पे non-final बन गया, and connected to the initial state of second automaton. ये initial state है second automaton का with the value known as epsilon. और यहाँ पे epsilon से connected. And finally, what you are getting, that is known as N1 concatenated with N2. Any doubt? And this is the proof of the theorem. This is the proof of the theorem. Here, what the proof is saying is the two automatons N1 and N2 is represented as U1, sigma, L1, small q1, and F1. And N2 is the automaton represented as Q2, sigma, del 2, small q2, and F2. Also, I can say that this N1 and F2 recognizes the language A1 and A2 respectively. And we have to construct a finite automaton which is represented with the help of 5 tuples Q, sigma, del, Q0, and F. Which will recognize the language A1 concatenated with the language A2. That is A1 A2 वाला language इस automaton में recognized होगा. Then how to construct it? By using the method of construction. The first one is the initial state. I am moving forward. The second point I am saying, the initial state of the first automaton becomes the initial state. And here you can see the state Q1 is the same as the starting state of N1, where N1 is the first automaton, N2 is the second automaton. Here the initial state of the first automaton becomes the initial state of the entire automaton. Similarly, moving for the concept of final state, the final state of entire automaton is the final state of the second automaton. That is the acceptance state F2 are same as the acceptance state of N2. Going for the transition function, as I told, the final state of automaton 1 is connected to the initial state of the automaton 2 with the help of epsilon transition. And here it is representing the transition function. Okay, can I move now next? तुम लोगों ने लिख लिया? Is it finished?
Yes, sir. 30 seconds, sir. 30 seconds.
I'm changing the slide. Now, what we have proved, if two languages are regular, then their union is also regular. Proof number 1. If two languages are regular, then their concatenation is regular. These two theorems we have already proved. Now moving for the theorem number 3, it says us that, is it finished now? I am moving for this.
Yes, sir.
If a language is a regular language, then applying the clean star operation on it, the result is also regular. Then who can say what is the other name of the star operation? Shruti Namra? Shruti Namra? शिखर स्वरूप? Shruti Namra, yes sir, बोल रहे हो तो बोलो. What is the other name of this star operation? जल्दी बोलो. Don't have time. What is the other name of the star operation? Can't say. Very good. Clean closure. Very good. It's also known as clean closure. That is, whenever we are applying clean closure on a regular language, then the result is also regular. Just a second. Then moving for this, the theorem tells us that the class of regular languages is closed under the star operation. It means if we have a regular language, A1, and then its clean closure, that is A1 star, is also regular. And how to prove it? We can prove it also by using the method of construction, and we can say that for the language A1, if we have designed a finite automaton N1, that is a NFA N1, then we can also design another NFA that recognizes the language A1 star. Understood? If there is an automaton N1, then we can design another finite automaton that accepts A1 star if A1 is accepted by N1. कोई भी लैंग्वेज अगर रेगुलर है उसका एक फाइनाइट ऑटोमेटा बन सकता है तो उसका क्लीन स्टार ऑपरेशन अप्लाई करने के बाद जो रिजल्ट है उसका भी फाइनाइट ऑटोमेटा बन सकता है. Then now we'll go for the design itself. This is the design of clean star operation. Shikhar Swarup, Shikhar. Shikhar. Hello?
Yes, sir.
If I'll go for a language, the language is A, then what do you mean by L star? If L is a language A, then what is L star?
Sir, we are applying clean closure in A.
हाँ तो क्या होगा रिजल्टर में क्या एलिमेंट है सेट में बोलो मुझे एलिमेंट क्या है उस लैंग्वेज में क्या एलिमेंट्स है बोलो
Sir, all the strings of finite length.
नो कौन बोल सकता है इफ
मतलब
देयर
कि
इज
sir,
अ लैंग्वेज
all the strings of finite length made up of elements of the given set.
सेट कहाँ पे यहाँ पे आ गया मैं बोला देयर इज अ लैंग्वेज एल व्हिच इज ए देन व्हाट इज एल स्टार A स्टार में क्या क्या स्ट्रिंग्स रहेंगे? ज्योतिष बोलो.
सर A double A triple A infinity times of A.
कुछ छूट रहा है मुझे लग रहा है.
A to the power 0
Epsilon.
means pi. Yes, sir.
Epsilon.
Epsilon
Epsilon.
pi. A to the power 0.
एप्सिलॉन और पाई. एप्सिलॉन और
Epsilon.
पाई
Epsilon.
कौन सा?
Epsilon,
कौन सा?
epsilon, sir. Epsilon.
Not पाई. पाई नहीं हो सकता. एप्सिलॉन.
Yes.
That means if I'm going for clean star operation of any element, then it contains epsilon and any number of repetition of that element. Then how I have designed that I am saying, this is your automaton. I have created a new initial state and made it final to accept the epsilon. This is for the case epsilon. Then I have connected it to the initial state of the automaton with a transition epsilon. तो मुझे बोलो अगर इस इनिशियल से इस फाइनल पे मैं पहुंचा जैसे भी रास्ते से आया तो मुझे क्या मिलेगा? When I traverse from initial to final, then what I get? What I get? अरे लैंग्वेज. अरे लैंग्वेज एक्सेप्ट होने का मतलब क्या है? If I am starting with the initial and finally we are reaching the final state, then only the language is accepted. Yes or no? अरे एक लैंग्वेज कैसे एक्सेप्ट होता है? अगर इनिशियल से
Final
शुरू
state
करके
में पहुंच जाएगा.
पहुंच गए तो ये डिजाइन क्या बोल रहा है तुम्हें? If I am starting with this initial, I am reaching this final. Then what I accept? ना L. मेरा L स्टार में क्या होना चाहिए? एप्सिलॉन, L, डबल L, ट्रिपल L ऐसा ही होना चाहिए. हाँ कि नहीं?
Yes,
अरे
sir.
ऐसा ही होना.
Yes,
Yes,
sir.
sir.
यहाँ इनिशियल से फाइनल पहुंचते पहुंचते मुझे मिला L. इप्सिलॉन के लिए मैंने ये बना दिया. अब क्या चाहिए मुझे? डबल L, ट्रिपल L ऐसा ही चाहिए. तो उसके लिए स्टार्टिंग टू फाइनल इज L. तो बिना इनपुट के यहाँ पहुंच गए. फाइनल टू इनिशियल गिव इप्सिलॉन ट्रांजिशन. अभी L में पहुंचा. इनिशियल से शुरू किया आके फाइनल में पहुंच गया L. तो फिर से यहाँ आ गया. फिर से आया डबल L. फिर से आ गया ट्रिपल L. फिर से आ गया 4L. फिर से आ गया 5L. ऐसा ही जितने बार चाहे मैं लूप में रिपीट करता जाऊंगा. इसीलिए मैंने फाइनल से इनिशियल तक इप्सिलॉन ट्रांजिशन किया. समझ पाए?
Yes, sir.
Anyone any doubt? Anyone any doubt? No doubt.
No, sir. Got it.
Then this is the proof. This is the proof part. Let I am going for a finite automaton N1, which is defined as Q1, sigma, del 1, Q1, and F1. This is recognizing the language A1. Now, we have to construct a finite automaton capital N, which is of 5 tuples Q, sigma, del, Q0, and F. And our goal is to recognize the language A1 star. To go for that, I can say that the set of states capital Q is the states present in N1 along with a newly created state. And this newly created state is Q0. You can see here, this is the states of the automaton, and this one is a newly created state. That is union of newly created state with Q1 is represented as Q. And that newly created state is the start state of the automaton. That means this Q0 is the new start state. Moving for the final state, I can say that whatever final state is there in N1, along with that, this Q0 will also become the final. That is the accept states and the old acceptance states plus the newly created start state. Here you can see the newly created start state becomes final and these all final states are as usual. And going for the transition, I can say the newly created initial state is connected to the old initial state with a epsilon transition. And for the automaton, the final states are connected to the old initial state with a epsilon transition. That means here you can see from old to old initial state, there is a epsilon transition from the final state. And by that we can construct an automaton which will go for accepting the language A1 step. Any doubt? Any doubt?
No, sir.
All of you have written?
No, sir.
No, sir.
Is it finished? Is it finished? तो फिनिश हुआ?
Yes, sir.
Yes, yes, sir.
नहीं करेगा.
Yes, sir.
नहीं काम नहीं करेगा. मैं बोल रहा हूँ वेट करो. जब बोलूंगा तब करना. लिंक दे दिया मतलब नहीं कि काम करेगा. Just wait. Then going for some more closer properties, we can say that complement of a language is also regular. If there is a language, regular language, then its complement is also regular. Intersection is a similar case. If we go for two languages which are regular, then their intersection is also regular. These are the things that we have already covered in case of DFA. Are you writing these things? लिख रहे हो?
Yes.
Yes, sir.
थोड़ा जल्दी जल्दी लिखना है तो. इसके बाद और एक स्लाइड है वो खत्म करने के बाद एग्जाम देना. तक रेस्पॉन्स ऑफ है. Then here you can see if I'm going for any language L, then its complement means sigma star minus L. Sigma star is the all strings present in sigma. That is, whatever strings possible using the alphabet set sigma is called sigma star. From that, if you are going to make a difference of L, then what you get, that is L complement. That means if I am going for the language L, it is regular, and we can design a finite automata N, then to go for its complement, already तुम्हें बोला है, अगर complement निकालना है, मतलब मैं बोल रहा हूँ length 2, उसका complement क्या हुआ? अगर length is not equal to 2, then उस केस में क्या करना है? जो ऑटोमेटा है सेम ऑटोमेटा रहेगा, सिर्फ जो फाइनल स्टेट है वो चेंज हो जाएगा. If there are a final state A, then in its complement वो फाइनल स्टेट्स नॉन फाइनल बन जाएगा और बाकी सब फाइनल बन जाएंगे. ये वाला एग्जांपल भी मैं तुम्हें दे चुका हूँ.
Yes, sir.
Similarly, if you go for intersection, ये सब बना के दिया है, इसीलिए फिर से बोल रहा हूँ. If you go for intersection, then if you have two automatons L1 and that accepts L1 and L2, that are two regular languages, on that case, we can say that its intersection can be designed and its proof is there with you in the case of proof of DFA. ये वाला पेज खत्म हुआ, क्योंकि अभी लास्ट पेज मेरा बाकी.
Yes, sir. खत्म हो गया.
Then the last two operations I am saying, set difference and reversal. If I am going for a set difference operation, we have two languages A and B which are regular, then A minus B is also regular. And here one line is missing. If you want, you can write, if I go for this A minus B case, then those states will be the final states which are present in A and not in B. And how to design that also I have given you in the case of DFA. You can see that the proof is there. I am not going for these proofs because these proofs are there with you whenever I have gone for the DFA case. And similarly, if a language is regular, then its reverse is also regular. And from this I can say a finite automaton is closed under, याद रखो ये वाला लाइन जो बोल रहा हूँ, a finite automaton is closed under union, intersection, set difference, complement, reversal, concatenation, clean closure or star operation, homomorphism, and inverse homomorphism operation. याद रहा, क्वेश्चन ऐसा आता है, कौन कौन से प्रॉपर्टी इसमें है, कौन सा इसमें नहीं है. मैं रिपीट कर रहा हूँ. The regular languages are closed under union, intersection, set difference, complement, reversal, concatenation, clean closure or star operation, homomorphism, and inverse homomorphism operation. Clear? Or any doubt?
Yes, sir. Clear.
Clear.
Anything to ask? Is it finished? I can close it.
Yes, sir. You can.
Okay. Now the link is active, but before going that, listen one line. Don't leave after answering. Okay. तो तुम्हारा तो कल क्लास है, मैं बोल दूंगा, आज नहीं चाहिए. ठीक है. Then you can go for the particular things that you can answer the quiz. Don't leave without answering the quiz. And now I am taking the attendance. Those people who are not here during attendance, their quizzes are also not considered. समझ क्या बोला? If you are not here during the attendance, then the quiz is not
Okay,
considered.
sir.
Just go for the attending the quiz. Taking the attendance, please respond. Abhijit,
Present, sir. Present, sir.
okay. Ankit,
Present, sir.
Parthasarathi,
Present, sir.
Tanya, you are there but left.
Present, sir. Present, sir.
Ashutosh,
Yes, sir. Yes, sir. Present.
Nikhil,
Present, sir.
Nikhil,
Present.
Rahul,
Yes, sir. Present.
Ayushman, Chandrakanta,
Present, sir.
Atish,
Yes, sir.
Jyotish, Pratyush,
Present, sir. Jyotish, present, sir.
Pratyush,
Present, sir.
Anup, Hariom,
Yes, sir.
Prithviraj, Sandeep,
Present, sir.
Trivikram,
Present, sir.
Smriti,
Yes, sir.
Yes, sir.
Rajiv, Rajiv,
sir. Present, sir.
Sikriti,
Present, sir.
Ambit,
Present, sir.
Krishna Murari,
Present, sir.
तुम इतना लेट में क्यों आ रहे हो? रेहान, रेहान, राहुल, राहुल मुखर्जी,
Present, sir.
दिव्य प्रकाश,
Present, sir.
केकाकुन,
Present, sir.
आशुतोष,
Present, sir.
देवज्योति,
Present, sir.
शिखर स्वरूप,
Present, sir.
सौम्य महापात्र,
Present, sir.
ईशक,
Yes, sir. Yes, sir.
अनन्या,
Present, sir.
राहुल मलाकर, सुप्ती नम्र,
Present, sir.
सुप्ती नम्र,
Present, sir.
सुशी,
Present, sir.
निकिता,
Present, sir.
निहार,
Present, sir.
निहार, शिबलू, शिबलू, कृष्णा,
Present, sir.
अभी,
Present, sir.
खैर, अंजलि,
Present, sir.
प्रियव्रत,
Present, sir.
दिव्य दर्शन,
Present, sir.
अलीसा,
Present, sir.
शुभेंदु, आदित्य,
Present, sir.
आदित्य, दीक्षा,
Present, sir.
दीक्षा, दीक्षा, अमृत,
Present, sir.
राजेश, सत्यनारायण सिंह, सत्यनारायण सिंह, प्रज्वल कुमार,
Yes, sir.
रूपम,
Yes, sir.
तुम्हारे सेक्शन के बच्चे ज्यादा एंट्री करने से क्या सोच रहे हो? उन्हें ज्यादा मिल जाएगा अटेंडेंस? नहीं तो मिलेगा। I'm closing the acceptance. I'm closing the acceptance. आदित्य कुमार, सत्यनारायण सिंह, राहुल मुखर्जी, सत्यनारायण सिंह,
सर ज्योतिष ने प्रेजेंट सर थोड़ा लेट हो गया था बोलते हुए।
दिया दिया दिया। इन लोगों को
Yes, sir.
जानता हूँ, उन्हें वैसे ही दे देता हूँ। इन्हें नहीं
जी,
जानता
Sir,
नहीं।
Aditya, present.
यही चीज होता है कि तुम लोग इंटरेक्ट करो तो पता चलता है कौन है कौन नहीं। इसीलिए हमेशा बोलता हूँ कि इंटरेक्ट करते रहो। अगर तुम क्लास में हो, तुम्हारा नाम याद है, तुम्हें आराम से दिया जा सकता है अटेंडेंस। नमस्कार। तो मुझे मालूम है तुम हो, अगर भूल भी गया तो दे दूंगा।
जी सर।
इसलिए तुम लोग इंटरेक्ट नहीं करोगे तो मैं कुछ नहीं कर पाऊंगा। थैंक यू। अगर सबमिट कर दिया तो जाओ।
थैंक यू सर।
Thank you, sir.